Okay, so this section continues with optimization problems. You're not done with them, but centers around business and economics problems. The procedure for solving the problems will be the same as what we used for other optimization problems. So find the number of units that must be produced to maximize the revenue function. What is the maximum revenue? So here they actually give me the equation. So is this a difficult optimization problem? No, but I'm still trying to find the maximum revenue. So it's still an optimization problem, not as difficult though. Okay, so how am I going to go about finding the maximum? Find the derivative. Okay, now let's just talk about the feasible domain for a second. What would be my feasible domain here? But has to be positive, right? Can it be 0? No, because that's not going to maximize revenue. So I would say probably 0 to infinity, not including 0. Okay. So let's just write it so we have it. So feasible domain. I'm just going to go, not always, but a lot of times with, especially business problems, a lot of times it's going to be something like that. Okay. Now we said to find the maximum, we take the derivative, right? So let's take the derivative with respect to x. What do I get? Negative 3x squared plus 300x plus 9375. Okay, do I need a secondary equation for this? Are there more than one variable that I need to deal with? No, so I don't need a secondary equation. I don't need to plug something into here. It's just one variable. If it's one variable, you're fine. That happened in your homework sum, right? Where, okay, there was just one variable. We don't need our secondary equation. Okay, what else do I need if I'm going to use a second derivative test? Probably the second derivative, right? And here the derivative is really easy to take, so I'm going to use the second derivative test. Whenever the derivative is easy, I use that. So take the derivative and I get negative 6x plus 300. And then what do I do? I find where the derivative is 0, right? So the first derivative is 0 when, does a 3 come out of everything? How can you tell with big numbers if a 3 comes out of it? If you add them all together and a 3 comes out of that number. So 9 plus 3 plus 7 plus 5, is that divisible by 3? Yeah, so 3 comes out of everything, so let's take a negative 3 out, so it's just positive x squared. If I took a negative 3 out, this is going to become minus 100x. And take a negative 3 out, it's going to be minus 3 goes into 9 3 times, into 3 once, into 7 twice, and into 15 5. So the first derivative is 0 when this is 0. Now we might not be good enough at factoring huge numbers like that. If you're not good enough at factoring huge numbers, what do you have to use? Quadratic. Good thing is you have Mrs. Rabbit here. So we have minus 125 and plus 25. So which of those numbers is not going to make sense? This one here, right? Because it's going to give me negative 25. That's not in my domain. So I know x has to be 125, right? Okay, now I go ahead and do what with that for the second derivative test? Plug it in the second derivative. So I take the second derivative at 125. Just looking at it, 125 times negative 6 plus 300, positive or negative? Negative. So it's less than 0, which means it's concave. If it's less than 0, it's concave down, so max or min? Max. So whatever Tom says, just do the opposite. Okay, so there's a max at x equals 125. That happens. Okay, so then let's make sure we, why is this staying there? Who knows? Let's make sure we just write the actual answer here. It says, what is the maximum revenue? So is this what I was looking for? No, what's 125 represent? the number of units produced, right? So if we produce 125 units, the revenue is how do I find it? Plug it back in the original, right? So is it over 1 million? Like 1,562,500? That's what I have. Is that what you guys getting? 125 into here. That's gonna. This is your revenue equation. Yep, that should give you that. So go ahead and check it. Okay, and that's what it asks for. What is the maximum revenue? So any questions on that? That one's pretty straightforward, right? So we're going to be talking about average costs. Whenever you see C bar, that is the average cost here. So if you think about an average, you take the total and divide by the number you have, right? So if we're talking about average costs, you take the total cost, which is your cost function, and you divide by X, which is the number of units produced. Make sense? Okay, so find the production level that minimizes the average cost. So if we're trying to minimize the average cost, what do I have to do for this problem? First, I have to find the average cost, and then I'm going to take the derivative and find the minimum, okay? So let's go ahead and get the average cost. So I'm going to write C bar is this function over X. Can I use the heart method where I split this into the 3 separate pieces? Okay, and so 400 over X is going to be 400 times X to the negative first. This is just going to become what? Plus 0.05. The X's cancel. And the last piece is going to be just an X to the first, right? Okay, so any questions on that? Let's think about the feasible domain. What's a feasible domain? 0 to infinity again, right? So I'm not going to write it here, but keep that in mind, because if we get an answer that doesn't work, we have to get rid of it. Okay, now what am I going to do with it? What do we say if we're trying to find the average, or sorry, if we're trying to find the minimum of this? We have to take the derivative. So let's take the derivative of the average cost with respect to X. I take the derivative, pull the -1 down, I get negative 400x to the negative second. What happens to the 0.05? Goes away because it's 0, and the back piece, 0.0025. Okay, now is second derivative test easy here? Yeah, so let's take the second derivative right away. Whoops. Use F. Okay, here the -2 comes down and gives me positive 800x to the negative third, right? Okay, now let's just think about this for a second. This is 800 over x cubed, right? Is this going to be positive or negative if my x's are always greater than 0? Positive, right? So if it's positive, it's going to be concave up, which is going to give us a minimum. And that's what we wanted, right? So this actually works out really nice. This should work. So what do I have to do before I, plug anything in the second derivative? Yeah, make the first one equal to 0. So I have negative 400 over x squared plus 0.0025 equals 0. Then I'm going to move the negative piece to the other side because it makes it positive. So add it over, I get 400 over x squared. What am I going to do now? Multiply by x squared, then divide by that decimal, right? And then take the square root. So go ahead and do those steps there. And what are we getting for x? 400? Sound good? 400? We get plus or minus, but the minus doesn't make sense here. And if I plug 400 in the second derivative, so I'm just going to, whoops, write it here for good measure here. That way I show my teacher that I did it. If I plug 400 in, it's greater than 0, which means that there's a max or min? Minimum and relative, we should say. So there's a relative minimum at x equals 400. And then we just have to make sure that we answer the question. Find the production level. So am I going to plug this back in my cost? No. What's my production level? 400 what? Units. So 400 units. Any questions? Again, pretty straightforward, right? Maybe a little easier than the last section for those. Just a little bit. All right, the next piece here. When calculating maximum profit, there are two different ways that it can be done. So obviously in business, it's important to try to find where the maximum profit is, right? Okay, one way is to find the profit function and then locate its maximum value just like we would for any other function. Okay, the other way is to look at the marginal cost and marginal revenue functions. If they're equal, you'll get maximum profit. So the big thing here is your maximum profit is going to be when the marginal cost, which is the derivative of your cost function, is equal to your marginal revenue. So now this is like what was on your last test, okay, or in the last chapter. Find the price that will maximize the profit for a product with a demand function of this and cost function this. So we have our cost function, right? What am I going to need to do with the cost function in order to set these equal? I need the derivative, right? Do I have a revenue function? How do I come up with my revenue function? Your profit is your revenue minus cost, but how do I come up with my revenue function? What do I do with my demand? I take x times my demand. Okay, so that's what you're going to do if you're given a demand function. You take x times your demand, that gives you your revenue. Okay, so this is going to be x times 40 over square root of x. What do I do with those exponents if this is in the numerator, this is in the denominator? Subtract, so what do I get? 40x to the half. Is everyone okay with that? Okay, so this is my revenue function here. What do I need to do with it? Take the derivative. So what's the derivative of my revenue? (20x to the negative half), and the derivative of the cost is? What is the derivative of the cost? Just 2, right? And then to find the maximum profit, because it says find the price that will maximize the profit, I set those two equal to each other. So I'm going to take 20 over square root of x. That's this here. I'm just moving that to the denominator, is equal to 2. How would I solve that? Times by square root of x, then divide by 2, and then square both sides, and I get x's 100. Does that make sense? Is that number okay? Is it in the feasible domain? Yeah. Okay, now let's just make sure we answer the question. So find the price that will maximize the profit. So is this the price? No. What's my price? This is my demand function, right? The price is equal to this piece here. So how am I going to solve it? I just plug 100 into there. So I'm going to say P of 100 there. So that would be 40 over square root of 100, which is 4. And what's my label going to be? Dollars, yeah. So it says find the price that will maximize profit. I'm just going to say $4 per unit. Or $4 each. I know, that's why it's acting up, because I've been neglecting it. Happens. Okay. Any questions on that? All right. Last page here. Okay, price elasticity of demand. This is actually kind of neat, I guess. If you're going into a business field, this would be something you could use for, you know, your business. So it might be something a lot of people don't use because they don't really, you know, think about it, but people who are math people probably do. Okay, one method economists use to measure the responsiveness of consumers to a change in the price of a model is to use price elasticity of demand. Okay, if a change in price has little effect in demand, the demand is said to be inelastic. So let's think about this. Okay, if I change the price of diapers, am I not going to buy diapers? No, I have to buy diapers. Okay, if I don't buy diapers, that's going to, yeah, it's like a necessity. So it says items that are considered staples, such as milk, bread, water, okay, things that you need. If you change the price, it's not going to change demand that much. It might change it a little bit. Maybe I'll change my daughter's diaper less often because I'm a terrible mother, okay, if they raise the price by a lot. But you're going to need those items, right? So it's not going to change demand that much. That's inelastic. I could do cloth diapers. That's gross. I don't want to do that. Seems like a lot of work. Okay, if a change in price has an effect on demand, it's said to be elastic. So maybe a certain car, they raise the price by a lot. Is that going to change the demand? Yeah, some people will still buy it, of course, okay, but it's going to drop the demand. So items that, you know, have an elastic demand would be like pop, candy, cars, things like that, things that you don't really need, okay? Definition of price elasticity of demand. Let's see here. If P equals f of x is a differentiable function, so we can take the derivative, then the price elasticity of demand is given by this here. So I would highlight that. Okay, for a given price, it's elastic if the absolute value of this eta, I don't even know how to say that, I'm assuming that's what it is greater than 1. It's inelastic if it's less than 1. And it has a unit elasticity, which means it's not really either, if the absolute value equals 1. Okay, now these 2 points are where it comes in handy, okay? If the demand is elastic, so if it's, you know, something like a car, then a decrease in price causes an increase in revenue. So if I decrease the price, more people are going to buy it, right? And I'm actually going to end up making more money. Okay, even though I lowered the price, I'm still going to make more money. Okay, so that's the first thing that I would probably highlight here. Okay, if it's elastic, decrease in price causes an increase in revenue. If it's inelastic, so diapers, if I decrease the price, is it going to increase the revenue? Do I go buy more diapers? Maybe you'd, you know, stock up on them, but if you decrease the price forever, am I going to go stock up on diapers? No, I'm just going to go get them as I need them, right? And I'm not going to, you know, have extras or anything. So if it's inelastic, if I decrease the price, it's not going to cause an increase in revenue. Okay, you're probably actually going to lose money if you decrease the price of that. Makes sense? So moral of the story, just increase how much diapers cost and you're going to make a lot more money, right? I think so. At least on me. So I'm not changing. All right, let's try. Find the intervals on which the demand function is elastic, inelastic, and of unit elasticity. So first I have to, whoops, let me go back up to here. This is what I need. I need p over x, and I need dp dx. What's dp dx the same as? The derivative. So let's find dp dx first. What's dp dx equal? What power is this to? P is 36, which doesn't really matter, right? Minus 2x to the 1/2. If I bring that half down, what do I get? Negative 1 x to the, okay, so negative 1x to the negative half, which is the same as negative 1 over x to the half. I think you might run out of room on this one, so just write small. Sorry for the late notice on that one. I know we wrote a lot so far, so. Okay, now if I do p over x, that's what goes in the numerator. My p is this, and my x is x. So p over x is 36 minus 2 squared of x over x. And what do I do with those two things? I divide them, right? To find this here, I'm going to divide this divided by this. So yep, you can multiply by the reciprocal, which is exactly what we're going to do. So if we take p over x, that's this here, 36 minus 2 squared of x over x. And if you divide by negative 1 over square root of x, that's the same as multiplying by what? Square root of x over negative 1. And it doesn't matter which one the negative gets paired with. So I'm going to get rid of this denominator. Does everyone see where that went? So instead of dividing, multiply by the reciprocal. Okay, can I clean this up a little bit? If I distribute this square root of x through, I would get 36 square root of x minus what? 2x over negative x. Okay, then here, if you want to, you can do the heart method. So this is, if I do the heart method, let's do this one first, because the two negatives cancel, so what do I just get? 2. So I'm just going to have the 2 out front. And if I do this one here, I have minus 36x to the what power? Negative a half, right? Or x to the half if you have it in the denominator. Okay, so any questions on where I got that value from? If I put these two pieces together here, I subtract my exponents. This is to the half, this is to the 1. So a half minus 1 gives me negative a half. Okay? Or you could leave it in the denominator as positive a half, which I might end up moving it back there. Okay, now I want to know when the absolute value is 1, when it's less than 1, and greater than 1. The easiest thing to do is find where it equals 1 first. So we're trying to find when the absolute value of this is equal to 1. Okay, now if you think about this, the absolute value of what equals 1? If n, or if this, I'm calling it n, if this is equal to 1, or if this equals negative 1, right? And what is this value? Isn't it this whole thing? So I'm going to set this equal to 1 and set it equal to negative 1 and solve. So I have 2 minus, should I put it over x to the 1/2? Is that going to be easier maybe? I think it might be a little bit easier. So 2 minus 36 over square root of x equals 1. I'm going to solve that. And then I'm going to do 2 minus 36 over square root of x to the square root of x equals negative 1. So any questions on that? What am I going to do for the first step to solve this? I'm going to subtract 2, which gives me what? Negative 1. And aren't they both negative? So can I make them both positive? Can I do 2 steps in one here? Okay, so let's, like I'm moving the 1 over here, that's going to give me 1, and move this over there is going to give me positive 36 over square root of x. And then multiply by square root of x, so I get square root of x is 36, then how do I solve? Square it, so x is equal to 1296. Now, does that fit in the domain they give me? No, right? It's 0 to 324, so that one I'm going to cross off. It's not in the domain that they give me. Okay, so this one hopefully works. If I move the 1 over here, I get 3, right, is equal to 36 over square root of x. Multiply by square root of x, so I have 3 square root of x equals 36. Then divide by 3, and I get square root of x is 12, so x is 144. Does that one work? Yeah, that fits in here, so it looks like 144 works. Okay, so now we can start concluding things. So therefore, if it equaled 1, what does that tell me? The elastic, inelastic, or unit elasticity? Unit elasticity, right? So I can say, therefore, unit elasticity occurs when x equals 144. Okay, so that's the first piece there. I always think that's the easiest one to do right away. Now, if I go ahead and try to the left of 144, so from 0 to 144, is that going to make the absolute value greater than 1 or less than 1? So let's go ahead and, yep, do you have a question? Here, the absolute value equals 1, right? And the absolute value of 1 is 1, and the absolute value of negative 1 is 1. So whenever this is 1 or negative 1, this is a true statement, right? Okay, so I set it equal to 1, and I set it equal to negative 1. That makes sense? Okay, now that I have 144, it's unit elasticity at 144, which means it's going to be elastic on one side and inelastic on the other side of 144. So from from 0 to 144, I'm going to try to find if that's elastic or inelastic, okay? So if I do the absolute value of this, so let me just do absolute value of 2 minus 36 over square root of x. If x equals, pick a value from 0 to 144 to plug in. 4. Okay, so if I plug in 4, square root of 4 is 2. 2 minus 36 over 2. What's 36 over 2? Negative, it's going to end up being negative 16. When I do the absolute value, it's 16, right? So if I go up here, is that greater than 1 or less than 1? Greater than 1. So if I'm going from 0 to 144, is it elastic or inelastic? Elastic if it's greater than 1. Okay, so I'm going to say demand is elastic. On the interval 0 to 144. And I suppose we can't really include 0 though, can we? Because we couldn't plug it in, so I'm just going to go like this. And we don't want to include 144 because 144 is unit. Okay, now if you think about plugging something greater than 144 in, this is going to end up being a fraction. If I take the absolute value, it's going to end up being less than 1. Okay, so it would work. So that would mean that it's what? Inelastic. So demand. But you can always check it to make sure, that you didn't do something wrong. So demand is inelastic on the interval. And what would be my interval? Not to infinity. To 324. There we go. Okay, so any questions on that? I don't know about the open and closed. I feel like it's always open. Let me just try to think. Okay, but let's say I use 324. What's square root of 324? Is it 36 or no? It might not even be close. I don't know. Oh, 18. Okay, yeah, that makes sense. 36 over 18 is 2. 2 minus 2 is 0. Okay, let's see. And 0 is less than 1. I feel like we should include it. I feel like Mr. 8 didn't, so I don't know. Let me just check on it really quick. Okay, but does it make sense that we don't use 0? Because if I use 0, this is undefined, right? And I don't want to use 144 for sure, right? Okay, so that stuff makes sense. Okay, so looking it up, it looks like we don't include it. And my thought process on why we don't include it is because at the end points, a function is not differentiable, okay? And it has to be differentiable. So let's just not include any of the endpoints, okay? And then here's your homework. I'm actually going to take 35 off and go to 33, okay? You're welcome. It was just a typo, but you're welcome.